The universe is kind of like it has its own accounting department, a cosmic ledger that keeps track of every single thing, from the biggest stars to the smallest atoms. Today, we're going to take a look at that ledger and tell the story of everything through two of its most basic rules: energy and entropy.
All right, let's just jump right in with a huge puzzle. Physics tells us that the total amount of energy in the universe is fixed. It's constant. It never, ever changes. So, if the amount of stuff never changes, why does time only move in one direction? Why is it a one-way street from the past to the future? Well, the answer to that is the second main character in our story.
First up, let's meet the cosmic accountant, the law of conservation of energy. This is one of the most fundamental, unbreakable rules there is. It says the total amount of mass energy in the universe is set in stone. Everything that exists now was there, in some form, at the Big Bang. Not a single drop has been added or taken away since. It just changes its shape.
And here's the other side of the coin. This is the force that gives the universe its direction. It's called entropy. You can think of it as the universe's natural tendency to get messier, more disordered. The second law of thermodynamics is simple. Total entropy, or randomness, is always going up. This isn't just about your bedroom getting messy. This is time's arrow. It's the reason time itself seems to flow from an organized past to a much more chaotic future.
So, to really understand this incredible journey from order to chaos, we have to go back, way back to the very beginning, to the universe's starting line, which was a state of maximum energy, but also, weirdly enough, a state of maximum order.
Now, this is so wild, and it's totally the opposite of what you'd think, right? We imagine the Big Bang as this messy, chaotic explosion. But in terms of entropy, it was the most organized, neat, and tidy moment in the history of everything. All the energy of the universe was crammed into this tiny, incredibly uniform state. There was basically only one way for things to be arranged, all smushed together. And that initial super low entropy is the only reason anything interesting could ever happen later on.
So how do we get from just pure, raw energy to us? The instruction manual was written by Albert Einstein. His famous equation, E=mc², tells us that mass is really just a super concentrated form of energy. And in the fiery moments of the early universe, this principle was the engine of creation, turning the raw energy of the Big Bang into the very first particles of matter. And man, did it happen fast. In just the first 3 minutes, the universe was this incredible cosmic forge. As it expanded and cooled from literally trillions of degrees, pure energy was constantly flipping into pairs of particles and their antimatter twins. This whole dance of creation and destruction eventually left behind the stable stuff, the building blocks for everything that was to come. A universe made almost entirely of hydrogen and helium. The cosmic game board was set.
All right, let's move on to the next chapter of the story, because this is where the universe gets really clever. It actually uses its unstoppable march toward disorder to create these beautiful pockets of incredible order, things like stars and galaxies.
Just look at the difference here. This shows the universe's grand transformation. It started out hot, dense, and incredibly smooth, a state of very low entropy, very high order. And it's headed towards a future that's cold, empty, and all clumped up. That's high entropy, high disorder. The entire story of the cosmos, all the stars and galaxies, it all gets built on the journey from one side of this chart to the other. Okay, so take a star. How does that work? Gravity takes these huge, uniform, messy clouds of gas and crushes them down into these tiny, intensely organized spheres. That looks like a decrease in entropy, right? An increase in order. But here's the cosmic trick. To create that little pocket of local order, the star has to ignite nuclear fusion. It becomes a gigantic engine for increasing the universe's overall entropy by blasting unimaginable amounts of heat and light, which is disordered energy, out into the cold emptiness of space for billions of years.
Okay, let's zoom way in now, from the cosmic scale of stars right down to us, right down to our own existence. Because if a star is a pocket of order, then life is an absolute masterpiece of organization. So how do we fit into this story of ever-increasing chaos?
And this is the crucial part. Life doesn't break the rules of entropy, it just found a fantastic loophole. In order to build our own incredibly complex, low-entropy bodies, we have to constantly take in organized energy from our surroundings. And in exchange, we pump out even more disorder back into the universe. We are literally borrowing our order from the cosmos, and we have to pay it back with interest.
And here's the cosmic invoice for our existence. Every single living thing on this planet is solar-powered. The sun, our local entropy machine, is busy burning through its highly organized nuclear fuel. Plants catch a tiny, tiny fraction of that energy to build organized molecules. Then we come along and eat the plants or eat animals that ate the plants to maintain our own fragile structure. But by doing that, we release body heat, we exhale simple molecules, and we basically just contribute to the great cosmic mess. We are living on the sun's entropic credit card.
Okay, so let's bring our cosmic accounting story up to the present day. We've followed the flow of energy and the rise of entropy. But what does the universe's balance sheet actually look like right now? The answer, it turns out, is way, way stranger than anyone expected.
So this is it. This is the universe's current budget. And honestly, it should shock you. Everything we see, everything we know and can touch, stars, planets, you, me, is part of that tiny little 5% sliver called ordinary matter. The rest? It's made of two complete mysteries. 27% is dark matter, some kind of invisible stuff whose gravity we can see holding galaxies together. And a whopping 68% is dark energy, this bizarre anti-gravity force that's making the universe expand faster and faster. We are just a little bit of foam on a vast, dark, cosmic ocean.
And it gets even crazier. If you look inside that tiny 5% sliver of ordinary matter, you want to know how much of it is the heavy elements we need for planets and for life? Carbon, oxygen, iron. It's less than 2% of that tiny 5%. It's an absolutely stunning reminder of how cosmically rare our kind of complexity really is.
So, if the arrow of time is driven by entropy, where is that arrow ultimately pointing? Let's fast forward and take a look at the final chapters of the cosmic story, when entropy finally comes to collect its entire debt.
Based on what we know right now, there are pretty much two main possibilities for how it all ends. The first is called the heat death. It's a slow, gradual fading over trillions upon trillions of years, where everything just cools down to a perfectly uniform, boring state of maximum entropy. But there's another, much more dramatic possibility, if that mysterious dark energy keeps getting stronger. It's called the Big Rip.
And if the Big Rip is what happens, it's a truly terrifying countdown. The accelerating expansion caused by dark energy would eventually get more powerful than any other force in the universe. About 60 million years before the end, it would start tearing entire galaxies apart. With just 1 year to go, solar systems would fly apart. In the final minutes, a planet like Earth would be ripped to pieces. And in the very last instant, the fabric of space itself would expand so violently that it would tear atoms themselves apart, ending everything.
It's a sobering thought, isn't it? But it leads to a really profound idea. We aren't just along for the ride in this story. In a very real sense, we are the universe itself, finally waking up and becoming aware of its own incredible journey from that perfect ordered beginning all the way to its chaotic end.
Which leaves us with this one last thought to chew on. What does it all mean? What does it mean that we are here at all, as witnesses to this cosmic story? The exact same relentless march towards disorder that will eventually destroy everything is also the process that allowed gravity to build stars, and for stars to forge the elements, and for those elements to build beings who can look up at the sky and wonder about it all. The engine of our creation is also the agent of our doom. What do we even do with a fact like that?